Okay, so we're going to start today by basically going over the thing that I gave you guys for your homework, and hopefully answer any questions you guys had about that. What I asked you guys to do was just make a simple sort of like parametric column, and we did that by taking one of the surface components, which was basic kind of like a basic sort of like shape here, like a cylinder shape, and adding a couple of number sliders to it to control the radius parameter and the height parameter, and that was all that you guys had to do. Okay, I'm going to go ahead and just make my perspective port big. I think that's probably good enough for now. And so you can get one of your components, and that's what I call these little containers here, like components, by finding it in the tab. What's the other way that we did it?
Double-clicking and searching.
Yep, double-click and search is going to bring that up, right? So you can do a double-click and you can search for cylinder. Okay, both ways are equally valid. And then once you had a cylinder, you went and got a number slider. Okay, and we can just look for a number slider. And I had you change the parameters for that. Okay, so how do we edit the parameters for a number slider? Yep, right-click, edit, and we can change the precision of it. For radius, I don't really need it to be very big, and I might rename it as radius, if I can spell radius, and then plug it in. And then once you plug it in, I can control the radius of it. What's another way that I can control one of the parameters for this? If I can change a parameter, let's say.
Right-click on the actual.
Yeah, to actually do a right-click on the parameter, go into set number, and then I can manually type in what that is. Okay, so the number slider makes it a variable, right? Makes it something that I can control, and I can control over a certain range. So I can say from 0 to 3, or I can say from 0.1 to 3. Okay, and the other thing that I can do is I can just put in a number for it, and then that's actually going to be like a static number, right? It's not going to change. It needs a number so that it has the size that I want it to be. But in this case, there's only one variable. Like that column or that cylinder is always 10, but the radius is going to change. Okay. Okay. And we could do different things. Like we could plug the same slider into two different parameters, and then we can actually have them both controlled by that. So now the height's 3 and the radius is 3. Height's 0.34, radius is 3.4. So we can have two parameters that are actually like dependent on each other. Okay. And so this is the kind of thing that we did. Okay. So that's one way to make a parametric object, is just to take an object that has parameters and change the parameters. Okay. But we're going to make something today that's a lot more complicated. I mean, in terms of the form, it's still going to be a column, but we're going to look at ways that we can make different kinds of cross sections. We can add a lot more sort of visual complexity to it, or I mean, more like actually the formal complexity of it. And so that's what we're going to cover. We're going to cover two basic methods for that. Okay, and your homework is going to be very similar. But before we do that, do you guys have any questions about what we did for the homework? Like for today? Everything pretty self-explanatory?
What's the way we disconnect?
Oh yeah, good question. Okay, so the question was, what's the way that we disconnect? If you do a right-click, you can say disconnect all, and that would, if it had multiple things connected to it, or you can say disconnect, and then you can choose the one, and it turns red, and then I'll disconnect it. If you erase the component, so I go in and I actually press delete, or I just go to edit and delete, that'll remove all the wires as well. Right? That makes sense. Yeah. Same with this component here. So go ahead and erase the components that you had. And let's start fresh. Okay, somebody asked a question in in the lecture on Tuesday, why don't we just extrude these from like a curve? Okay, that's something that we do in Rhino really often. You take a cross section and you extrude it, and that gives you some more options, because you might have a different cross section than kind of a boring circle. But and that would give you the height, right? So that's going to give you height. So let's go ahead and do that. Let's start in Rhino around the origin. okay? Just take a polyline and draw a shape. I'm going to do like a funky star. Okay, make it a closed shape, okay? So if you turn your snaps on, have it snap to be closed. And it just has to be around the origin. Okay, it can be curved, you can make a polygon, you can make an ellipse, I don't really care. Just a closed shape around that. Looks like everybody's got that. Okay, so once you've got that shape, there are different things you can do in Grasshopper. Like, you don't have to start with a component or start from nothing. As you guys saw in lecture on Tuesday, you can actually use objects in Rhino as a reference when you're making things in Grasshopper. So you can start with what's in the rhinoceros world and then edit it using Grasshopper. So what I'm going to do is I'm actually going to take, these are kind of like raw parameters here. These are going to be references. Under the geometry tab, this is a curve, okay? It's not a line. The line's like a single line. It's actually a curve, right? So I'm going to drop this in, a curve. You could also, just search for curve. And it's this little black thing that has like a hexagon. That's going to be, that's a representation of that, okay? And then I'm gonna pick that and right-click it, and I need to set that curve. So set one curve, and then I'm gonna pick the curve in Rhino that I want to reference. Okay, and it'll turn green. A little hard to see here, but that's going to mean that we have a reference for that curve. Okay, I'm gonna turn the line up here. That's a little bit better. I'll turn that front one up. Here we go. Yeah, if you try to click elsewhere. It's fine. Yeah, it might look yellow, but that just means that you still have it. That means you still have it like selected. If it's yellow, that means you still have it picked. If I pick somewhere else, then I haven't selected it. It's green. If this is green, then, or if this is the color gray, it's fine. Okay. Okay. So then we're going to extrude it. Now, if I didn't know where extrude was, how would I find it? Double click. Type in extrude.
So we can't extrude it in Rhino. We have to extrude it in.
You don't have to. We're going to. Okay. Like, yes, you could extrude it in Rhino, but what would happen if we just extruded it in Rhino? Like, what would be the disadvantage of that? It's not parametric. Yeah, right? You're like stuck with it. Okay? Okay, so this is extrude. It's the first time we've seen extrude. So if you have a component, what's the thing we need to know about it? What are B and D? Okay, so B is geometry, and it says it wants a profile, curve, or surface. Okay? So B might be the bounds of it, let's say. The letters don't necessarily mean what it is. What you want to do is read it and see what it wants, okay? It wants geometry. It wants a curve or a surface. Do we have a curve? All right. So plug that in there. Oh, but it's still not doing anything, though. It's orange. Okay. What is D? D wants a direction, and it says it's a vector, right? We're looking at that type, okay, the last word in that, okay? So we want a vector. Now, a vector, we've kind of talked about this when we talked about some of our system code. A vector is basically some kind of a line, but it's a point in space, and it has some kind of like direction, and it has a magnitude. Okay, it's an imaginary thing. Okay, so we want a line that points to where we want to extrude. Okay, which direction do we want to extrude this? X, Y, or Z? Good, yeah, Z. And if you don't know, you can look at the little thing here, like the compass rose, and you can see that Z is up, X is going like this way, Y is going this way. Okay, green is the Y, red is the X, and negative Y would be this way, negative X would be this way, and negative Z would be down. Okay, and you guys are right. Z is what we want. So if I want a Z vector, how would I find that? Right? What's that?
Right click on D.
Right click on D. Okay. No. How would I find it? I want a Z vector. Like, it wants a vector, and we want a Z. How do I find a Z vector component? Type it in. Okay, so how do I start doing that? Double click. Z. Oh my God, unit Z. Unit vector parallel to the world axis. Okay, so yeah, so we're gonna drop the search in Grasshopper is really smart. Okay, 99 times out of 100, it's gonna help you. Okay, if you don't know what you're looking for, start typing it in. It's like going to Google. Okay, you never know like what you're gonna find. But okay, so it's a Z vector, right? V for vector is our output. D, it wants a vector. Oh wait, oh, there, we got an extrusion. Okay. But what's missing in this? The unit. Okay, so we're looking at the unit multiplication. What does that want? And how do we put numbers into things? Sliders, yeah. Make a slider. What I don't want you guys to get into the habit of, I mean, it's one way to think of this is just to think of patterns and think of like, oh, if I want to extrude something, I just need these components and I make this thing. And that's one way to think of it. But what I want you guys to think about is, if I don't know what I want, how do I figure it out, all right? So how do I know what it wants? How do I find that component, okay? So these are the kind of strategies. You want to look at the inputs, and then if you don't know, you want to search for that thing, and then you want to try that, okay? I'm definitely going to teach you patterns, but at some point you're going to need to figure some of these things out. So let's go ahead and connect these, and lo and behold, yes, that is a parametric. What happens here? Like this turns red. Can't have zero extrusion. How would I find out what's going on with this thing and why it turns red? If you go up to this little box here, right? This little red little thing. You could also do runtime errors, I think. Yeah, curve cannot be extruded. Okay, it can't be extruded because it's 0. So what could I do to this to make sure it's always legal?
Set a minimum value.
Yeah, set a minimum value, exactly. So I could say anything. I could just say it could be 0.1. Okay. And I'm going to make this 30 or something like that. Okay, so now we have a much more interesting shape. Okay. Any questions about that? Does that seem to make sense? Okay. So with our parametric column, our cylinder, we had 2 parameters, right? We had the height and what else? Radius. Okay, radius. How could we change the radius of our cross section, let's say? What kind of operation would make the section bigger or smaller?
Lofting?
Not yet.
Okay.
But no, think about different things. We can move things, we can rotate things, or we can scale. Yeah, somebody said scale. Yeah. Scale things. Okay? So if we scale that section and then extrude it, like we can actually get the kind of parameters we had in our parametric cylinder. Okay? So how would we figure out how scale gets in there? What's that? Type it in. Yeah, well, double click and scale. Oh my gosh, it comes right up. Scale. Okay, what does scale want? Scale wants geometry. Scale wants a center of scaling. That's interesting. And it wants a factor, which is what? A number. Okay, what geometry do we want to scale? The curve. Good, okay. Yeah, so let's put the curve in there. And if you look at what's happening. Now, one thing I'll mention to you guys, we haven't talked about this much, but so you can see when you put the mouse on one of these, when I click this, it turns green, right? When I click the curve, remember the curve was green down here. I can hide those. Like I can if I it's still there, but I can turn off the preview for this. So now I can see that this is the scaled curve. This is the original curve, and that this is the scaled one. Okay, so they're all there, right, in the sketch, unless I turn those off. I mean, unless I do the preview. If I disable them, that's the Rhino one that's underneath it. We can hide that too. Just press hide. Okay, so again, I can turn on preview and I can turn off preview for that. So the scaled one is this one. It's 0.5 of the original geometry. Okay, and let's put a slider in there. So now I can control that, okay? But what's happening here, it's not actually extruding, okay? So what do I need to do? Like I have my curve that I scaled. What do you think? This wants a curve, and I've got one curve here, and I got a scaled curve here. Okay. Yeah, so I take this geometry and I connect it to this, and see what happens. Like that connection disappears, and so now this is it's using this. Okay. So again, now I have radius, and I have height. So I have redone the kind of cylinder logic, but with a different cross section. Okay.
So two connections cannot be possible at one point?
You can make two connections. What you can do is, if you hold down Shift, and you see a little plus pops up, and then drag this to the B, what happens? What happens? Show me. Tell me what's on the screen. Yeah, you get both of them, right? Because you're sending one curve, and if you look at the B here, see, it's got two values from two sources, okay? This is going to be really important later. We don't have loops in Rhino. So what happens is that you just pipe more than one object into it, and that's your loop. It just does it twice, okay?
Can you explain how you put both of the pipes into?
Yeah. Yep. Now you'll notice that the undo doesn't work. If you want to undo something, you gotta kind of go to Edit, Undo, because it gets confused by Control Z. So you gotta undo. Okay, if you want to make multiple connections, hold Shift, and you can drag it in, and you can have multiple connections. If I want to get rid of that connection, but I don't want to undo it, how do I get rid of that connection? Right click, disconnect. Yeah. And this is where this comes into play, right? Is like I can disconnect one or the other. I'm gonna disconnect the curve because this is really what I want. Okay. What would happen if I connect this? So I'm going to go back to what we had. So I get this guy. What would happen if I connected that to this? And then what's it going to do? So I connect the extrude, I extrude it, I have curve, extrude it, and then I scale it. What's going to happen? Yeah, it's going to scale what? Which object? Like the green thing, right? This is green. Okay. If I scale it, what happens? What's that?
It's bigger and smaller.
Yeah, it gets bigger and smaller, right? So if I plug this in, now again, I got to hide this one because the scale one is what I'm interested in. The one inside, see what I mean? So you have to get in the habit of hiding your previews. Okay. So just like in processing, so this is differently parametric, right? This is scaling the whole thing. It's not just scaling the section and then extruding it, it's extruding it and then scaling it. So just like in processing, the order of these commands matters, right? You got to pay attention to the logic of the system to get what you want. If you do things out of order, it's going to give you results that you don't expect. Okay?
Can you show me how to hide again?
Yeah.
Which one am I clicking on to do
Just
that?
do a right click and it's preview. It's the little person's head here.
Okay.
And that's going to, so it's green, and then if I hide it, it doesn't show up. And you see these turn gray, like dark gray? Some things aren't ever visible, like this vector. If I unhide my curve, see that's the original curve. Yep. Because again, all of these are different states of the sketch. So of the sketch. So it starts off as a curve, that's a state, and then I modify the state of it, then I modify the state. All the states are there and they're visible. And then now how do I, just to refresh your memory, I didn't talk about this in the demo, but how would I get this into my Rhino model so I can actually play with it? Bake it. And how do you bake something? Right click and then the egg, which I don't know why fried egg is the icon for bake, but we'll go with it. Maybe it's a baked egg. See, and now I have an instance of that. Now, this, you know, if I change the size of it, and I make that, I get a different one, okay? Okay, let's delete those. So yeah, always think about, you know, how you're gonna get these out of there. So again, the order matters. So that is one way to create a kind of object that's like a column. Okay, so you can scale things, and you can reference geometry. Those are the big things I want you guys to know. And again, always look at what the thing wants, and then kind of search for it. Okay. Okay. Any questions on that piece for now?
Why are you showing me? Sorry.
How do you make it look pretty? Is there a way to like auto format sort of things you want?
Oh, okay. Yeah, it does get kind of ugly. You guys saw in the video, there's no auto format. I wish there was. Goodness, man, maybe I gotta write one of those. But you can select things, and then you can use these things to align. So I can align them by the top, or by the bottom, or by the middle. Okay, and then if I want to, I can align these guys in different ways. Okay, Mr. Sparkle. And it's up to you how to arrange them. We'll kind of work on this as we go, like what the best looking arrangement is for these. You know, like which one makes sense. Generally, though, what I don't like to do is things like this where, you know, the chord for this is like all the way over here. It's like things are kind of in the order that they're supposed to be, and it's clear where things like start, and which ones I can modify. Like I like to line these up sometimes. Okay. And I told you guys about zooming and panning. So to zoom, you just use the mouse wheel, and pan is the right mouse button. Okay. Yeah.
Why do I see both of them together?
Because you didn't change the preview. Okay. So you'll see two things, because you have to turn off one of them. You have to turn off the preview of it. Okay. Everything. Otherwise, you see everything in the thing. Okay. Yeah. You're gonna have to get used to that. Good. Any more questions about that? We all set? Okay. Next thing we're going to do, let's delete these. Next thing we're going to do is talk about a different way to make a column using more than one cross section. And Michaela, this is where we do lofting. Okay. You guys know what a loft is? Did you see a demonstration of a loft in your thing? Okay. Just for the sake of argument or whatever, I'm just going to make a quick one just to show you. So I've got a couple of cross sections here, and if I, you know, change the scale of it, of like that section, and then I loft these together, I get this kind of geometry. Okay, so it's essentially a surface like a nylon stocking that's stretched over cross sections. All right. So that is certainly another way that we can make a column, and in fact, a more complicated column. And you could loft different cross sections together. That's okay. I'm just showing you the same section. You could have, for instance, like a hexagon in the middle, or like an ellipse and then a square and then a circle, and it would morph between those. Like it's very smart. But we don't need to worry about that right now. All right. So let me go ahead and delete those. And let's go back to perspective again. So that's our goal. We're going to do essentially a parametric loft, and that's going to be our column. Okay. So we're going to use kind of similar logic to the last one to start with. I'm going to start mine with a circle. Okay, for the sake of redundancy, how would I find that curve? I want a circle that's a curve. How do I find that? Come on, guys. Yeah, double click, type it in. Circle. Oh, look at that. Create a circle defined by base plane and radius. Okay, and you can see it if you look in the world. There's a circle. What does a circle want? It wants a plane. We'll leave that for now. We won't mess with that. And a radius, okay? So we can certainly control the radius with a number slider. And in fact, why don't we just make one? and I'm going to make it maybe 3 or something like that. Okay. Wow, I have a circle. Okay. Now it's a curve, right? That's just a curve. Let you guys build that for now.
Is there any way to copy and paste like a number slider so you don't even have to type it in?
Yes, there is, totally. You can actually just do like Control C, Control V, and it'll copy it, okay? Yes, you can definitely copy paste. And that is a great time saver. You can, in fact, you can copy paste this whole shebang, you know? And I got 2 going on here, okay? And in fact, we will be doing that shortly. Good question. Yes. Okay, so the magic happens here. What's going to be different? Last time we extruded this thing, okay? One way to make a copy of an object by moving it, to make a copy of something in space is to move it, okay? Because when you make a copy of something, remember how like we just had this problem where we had all these different states of the drawing at the same time, or of the sketch. We had this curve, and then we had this the scaled copy of it, and then we had that extrusion. We can use that to our benefit because if I have like a Rhino component or a Grasshopper one that moves something, I have the one that I had and the one that I moved. Okay, so now I've got 2 of them, and if I loft those together, right, I've got a loft. Okay, so if I want to make these things, an easy way to start making these things is to move them. So I'm going to move. Translate an object along a vector. Oh, those nasty vectors. Okay, so what does it want? It wants geometry. We've got some geometry. Let's plug that in. It wants a vector. What do we want to do? Like, which direction do we want to move this? If it's a column, let's say. Well, we got 3 choices. Let's pick one. Z. Okay, how do we get a Z vector? Type it in. Z. I'm going to keep saying that. Okay, and then we got vector. And see, look at that. Now we got 2 of these. Okay, and then what goes into the unit? Well, it wants a number. Slider. Number slider. Let's get one of those in there.
What makes it copy it and not just move the one that you started with?
What makes it copy it?
Yeah, like it made it 2. Why didn't it just move it?
Why didn't it just, oh, what makes it, okay, because it's already got 1 in there. So it's just at 1. So there's one this is the base one that I made, this circle. Okay, this one down here. And then the moved one is the one that's up here. And it's just, I moved it 1 in space. Does that make sense? So now you have 2. You have this one, they're both valid, but you have 2. Okay.
What would be the difference between a move and a copy?
Nothing, except that the move produces the copy by moving it. It's actually not a copy, right? It's a state of the drawing. I'm just moving the thing in space. But the fact that I have both states turned on at the same time makes it like as if it was a copy. Do you guys understand the difference? Okay, so again, the move component moves it in like space. Okay, it was here, it's now there. Okay, if I hide this one, if I turn preview off, there's only 1. Okay, like it's moved along. Okay, this component moves it. But if I turn this on, if I maintain both states at the same time, it looks like I have 2 copies of it. Does that make sense? Okay, it's a little the logic of it. You can think of it as a copy, if that makes you feel good. But it's but it doesn't. But it's different. Okay, it's a state of the script.
So does the original kind of like not exist?
Oh no, it exists. I mean, I can plug that into an extrude and extrude that separately, unless I don't. If that makes sense. We'll see. I'm going to show you some stuff and it'll all make sense. This is a little trickier than processing because the state of it is persistent. Okay? Like processing, nothing happens until you run it, right? And every time it runs through the loop, it rebuilds everything. This is like the state of the world, right? And if I change it, like the state, you don't see a loop, right? It's just there. It just seems like it's there, okay? Okay, so let's put one of these. I'm going to copy this. copy paste a slider, and I'm gonna make this Mas Macho slider. It's gonna be bigger. Okay, so now it's got a bigger range. Okay. Okay, now I'm gonna do something else here. What if I wanted to change basically change the radius of this, or the size of it? You can add a scale factor, exactly. So let's add a scale factor to this geometry. G to G?
Yeah, and you can add a slider number for it.
What's going on here? The center of the scaling is at 0, 0. The center of the scaling is here, okay? So what I'm going to do is, I'm just going to plug this in. Oh, sorry. Plug the G into the center. I'm going to use the same thing because I'm using the center of that shape now, right? I don't want the world center. I want the center of that. So you can plug one into both of these, okay? And see, this is crazy, but this is this one, and this is the scaled state of it, okay? They both exist, but I don't care about this one anymore. So now I got this and that, all right? And yes, just like Yashka said, you can put a slider in there for scale, and I'm gonna make this only a scale between 0 and 1, though, because I don't want to get bigger than the other one, okay? Okay. So I had this, I moved it, and then I scaled it, so now I've got 2 sections, okay? This is going to get crazy. I'm going to take these. So I'm going to hold shift down and just pick these. So I pick. I'm going to copy paste those. Now you see that one stays connected, that won't last. I'm going to take this geometry and I'll move it. And oh, I hid this, it doesn't show up. Okay, So now that copy is based on this copy. I mean, it's based on that move, okay? So I have different, and this one I'm gonna make taller. It's like 10. So this one's gonna get taller. Do you see what's happening? Do you see what's emerging here? Starting to become more like a column, more like a Doric column. Let's say it has a base, it has a shaft. Okay. So do you see what happened? So we kind of keep adding to this geometry. Look at all these parameters. Like we start to line these up with each other. You can redistribute them. So there's if you click this top one, it kind of gives them a nice even spacing, so they're pretty. Okay. So now I have these parameters. I have the radius. Oh, and check that out. The radius of them is all dependent upon the original radius, right? Because I took that state, I moved it, I scaled it, I moved it. So they're all dependent on this. Parametric.
Even the scaling number is controlling the scaling parameter and also controlling both the circles.
Well, yeah, and I'll talk about that. So this base parameter controls everything that's further down the stack, right? This parameter controls the height of that, which controls everything that's after that, right? This parameter controls the scale, which controls the other state of it that I moved, okay? So you see how these are like building upon each other and they have these different kinds of like dependencies on each other, okay? If you didn't want them dependent on each other, you would make them so that they're not connected to each other, right? You might have a new circle that you then move and then you loft that together, okay? But these are all dependent on each other, okay? You can do all kinds of things with this, and that's what we're going to do later, but I just want you guys to get the idea of it. So just different patterns of it. And let's go ahead and make this a loft now. So how do we do that? We're going to add a loft component. Okay, how do I get more than one thing, more than one wire, to go into a component? Shift, exactly. So it wants sections, which are curves. Okay, we have a whole mess of curves, right? That's a curve, and that's a curve. So we're going to take the mouse and we're going to put it in, and then we're going to take this one and we're going to plug it in, and we're going to take that one and we're going to plug it in, and we're going to start to make that a loft. Okay, and that's going to be parametric. So if I adjust these, whoa, Yeah. Okay. It's kind of like a wine glass, actually. Look at that. It gets thinner. It's on NutriSlim. And then it's a column. So you'd see, look at all the variation that that even has. Okay. Now, to make this more column-like, I'm going to go ahead and take the options here. O. I'm going to right-click that, and I'm going to go into Loft Options. And I'm going to change this to a straight loft. And then commit. And that will actually square it off. So now it looks more Doric. Okay? It's not going to smooth it. It's just going to create like a nice crisp line from piece to piece. Okay? Now, that was a lot. Do you guys have questions about that stuff?
Is there a way to rename or title those boxes?
Yeah.
Because I could see having.
Yeah, you can double click this. I mean, you can right click it, and you can scale. Scale is cool.
Well, like, so you said this is a curve, this is a curve, this is a curve. Can you just say curve 1, 2, and 3 or something? Like,
Yeah,
you know
exactly.
curve.
The thing is, though, I mean, you can do that, and I see people do that, but these are components. Like, that's a move component. That's a circle component, right? If you start calling it something like else, I find that later on, I'm like, what was that? Like, I mean, it helps you because you're like, that's curve 1. But I'm also like, was curve 1 a move, or was curve 1 a scale, or
You could write like move curve 1.
You could do that. You could do that. What I like to do is I just name the components. I mean, I name the sliders and not the components. But you can do whatever you like. You could also, guys, put a comment box next to it, so you can drop this little panel component from special. And then you can change the size of this, and you double click it, and you can say, hands off my curve. And you can label, you can put labels next to it. So these are like comments in 3D space, or in 2D space, okay?
So how did you do that?
You go up to this little thing here, like the yellow thing, like the panel, and you put it in, and you double click it, and say this is new text. I really hate the font on these, the Comic Sans. I think he's messing with us. And you can adjust the size of this. You can type in like paragraphs of text if you want to, okay?
So what, I guess I understand why we did it, but like, couldn't you just copy the circle and change like where it lies on the X and Y or Z or something and like plot them that way? Yeah, they just wouldn't, I know why we did it,
Yeah.
so they're dependent on each other and so like,
Yeah.
you can move them all together, but like, I don't know.
This is what we're going to be talking about. So that's a basic thing, okay? And so, let me delete this real quick. So by doing this, it's one kind of logic, right? You can say that this thing's going to propagate down the stack, like so that if something changes with the radius, it's actually going to contribute to that entire form of it, right? So there's a logic in it, and it's also way faster than going in and editing all those things in like your Rhino file, right? What we're going to do though is for your assignment is that you're going to do a column system that is a proportionate system, okay? So you're only going to have one parameter, but it's going to control that geometry to make a column, okay? And I'll explain that in a second here, okay? So this is one way to do it so that everything controls everything, okay? But I'm going to go ahead and delete these. Okay, so now you've got a lot of this stuff here. So this is let's see here. Let's shorten this up. So you might have one thing where the radius of the column, let's just say for the sake of being academic here, is going to control this next move here, which is the height of this, right? And you can put those two things together. You can change that relationship by using some math. So we can right-click this, go into the expression, and we could say that the height of that is 2 times the radius, okay? Or 1/2 the radius, okay? So to do that, the component is f, like the thing. You can go into expression, and you can say f divided by 2. And so now, this parameter is actually controlling like both of those parameters, right? There's a proportional relationship with those, like that's going to be maintained, okay? Okay. Another thing that you can do is actually just to go in and say, okay, so I have this curve here. That's the one that gets moved actually, and then I scale it to make this thing. If I don't, what if I don't put in? I don't control it parametrically. I set it, and I say that it's always like 0.667, so it's always 2/3 of whatever that is. Okay, so when this changes, this curve is always 2/3 of that. Okay, so that's a relationship. It's not directly controlled parametrically, but it's dependent on the other thing. So that's a proportion. Okay?
Did you just write like 2/3 when you did set number in that one?
I just did 0.667, but you could do that. Let me undo this, sorry. Expression, oh wait a minute, no, sorry. I went to F and I said set number 0.667. I think you could do 2/3.
Okay.
I think that works. That's probably more precise. Okay, so that has a relationship. And then I could go into this move parameter and I could do something similar. So I'm going to plug this in, and I'm going to say this is going to vary, and I'll say that maybe this value right now is 3 times the radius. So let's see, I think it's F. So I'm going to do F times 3. Okay. And so that creates a proportional system as well. And actually I want to do it maybe F times 5. Now you guys have seen lots of examples of proportion in architecture. You guys have looked at columns before. I mean the actual classical orders of columns. You've looked at things like the modulaire before, right? You've looked at the golden section, different proportional systems, right? You could subdivide a column into a particular kind of logic such that anytime you made one, if I change the height of it, it maintains that proportion. Or if I change the width of it, it maintains that proportion, right? So this is the kind of thing that I want you guys to think about, is like, how would you encode these things? How would you create a series of relationships with these so that you have a modular, you have a parametric column that has proportion, okay? Proportions are relationships between things, okay? So this is the idea. So for the assignment is you're going to, copy these cross sections, move these cross sections. You're going to scale them. You're going to, but the way that you do that is going to be controlled by a single parameter and a lot of logic, and that's going to make it proportional. Okay. Let's keep going here, and then I can maybe answer some questions you guys have. So that's an example of a really basic, lame one. What if you went in and then took, this piece, and you could always change, that section. Let me go ahead and disconnect that last one here. Is it this one? Circle, move. Yeah, and unplug this one instead. Okay, so I can actually change that section. And that could be a proportion, like maybe I make that's 0.667 of that, which is 0.667 of that one. So that is a proportion. Maybe I don't want that. Maybe I want that to be, 0.5 of that. Whoa, actually that's not what I want. I made that 5, I think, yeah, 0.5. So the scale is going to be 0.5. And so that becomes a different kind of column. Maybe it tapers, it comes back. Maybe it starts off tapered, and then it gets bigger. Lots of different things of columns you can do. And then you guys would want to add some kind of capital probably to it, okay? You can create different sections. You don't have to do it like this. If I went ahead and so I have this piece right here and this one. I'm going to go ahead and actually just pop out all these and disconnect all of them. If I reconnect these in a different order, so if I go circle and then this one, and then this curve, and then this curve. So I can actually create that kind of condition. Okay, do you see that? So it lofts to here, and then it lofts across here, and then it lofts up. So again, this is why having those other states can be interesting. If you decide to use them, you can create a different thing. So I could have the same kind of capital up here, that same kind of logic in this. maybe like the capital is twice as tall as the base. You have a heavy capital. Okay, maybe it flares out even more at the top. Okay, and then again, if I vary this parameter, these are all going to be proportional. What if I might do a thing though where I vary the parameter, but this is always the same. Let's take the math out of here, and I'm going to say this is always 3. Okay, so I can start to do things like that, but see that always stays 3. Okay, so like what if that's an important, you know, what if that's an important like datum line in your building? Okay, so that's part of that could be part of your like logic as well. Okay, what if the last one is always the same? What if the height of these is always the same? So I go in and I might change the this one too. So let me go ahead and I'm gonna get rid of the math here and make that one. I screwed that up. I need to disconnect that one. Set number, it's 18, it's always 18 feet. 18 feet is very important in my building. So now the proportional logic is there because, again, it's 2/3 of that base and then another and then half of that for the top of the column. The two datums are always the same, but the radius is like changing. Okay, so that's a kind of relationship as well. Okay, does this make sense? You see how powerful like that could be though? Once you understand, if you understood your design. So when you do these, and I'm serious, you want to sketch these first, okay? Like draw in AutoCAD or on paper a diagram of the proportional relationships that you guys want, okay? And then encode them. This is like the same thing we always talk about with processing, okay? You guys want to sketch and then encode, okay? And then one last thing, we're going to be like a minute over, but I want to show you guys, this is an important thing that's going to be different about this. Right now we got one thing. Okay, I want you guys to look at these as a row of columns because you really can't talk about proportion without more than one thing. I mean, it's kind of naked right now. So what I want you guys to do, everybody do this when you do this in your thing, is just take a line, start it at 0, 0, and then make and then basically make it so that it's like 100 at 100, 0. So it's a line that's 100 units long. Okay. You're going to do that. You're going to make a line. Okay? So I've got, I must have like raised it. So a line from 0, 0 to 100, 0. And then that's going to be it. You have a line, okay? Now, you're going to do something. You're going to take that and you're going to add, you're going to take a curve component. And then you're going to take a curve length. Curve. Length. No, I want the length of a curve. A division, yeah, thank you. Yeah, division, divide length. So it says divide a curve into segments with a preset length. Okay, so I'm going to plug my curve into there, set my curve. Okay, so that turns green. And then I am going to, you could take a slider for this. And you can set a range of things. Make it really big right now. Plug that into the length, and whoa, lots of points. So what this is this is going to divide it by a certain like length. So if I divide 100 by like 10, I'm going to get roughly 10 of these. Okay, 10 points. Okay, so I got points here. If I plug that in to here, something messed up. You want to right-click this and just say graphed for now. You get columns. You get as many of these as you want, and they're all parametric. Okay, so this is the idea. I am actually like recording this, so if you don't have the notes for this, like it's being recorded. So, but for the assignment though, take this structure that I showed you, like make a line that's 100 long, plug it into the divide length like component. Okay, plug that into your parametric column, and then graft it. So you're gonna right-click and say graph. We'll talk about that next week, what that actually means. Okay, that's going to send a list of points to that initial parameter, and since everything is, everything is basically like dependent on that, you now get like 10 copies of your column. The length between these is another proportion, right? So you could say that as the columns get taller, like the distance between them gets shorter, or vice versa, right? So that is also, so maybe the length controls this whole thing. Now we got to go back and fix all this, but, okay? So somewhere, you are going to have a parameter that's going to control everything in your sketch, okay? And so the length of it, so now check that out. Like they get skinnier, they get thicker, right? Because maybe in order to support more weight, they get bigger, okay? You're gonna make this system. You're gonna make me a diagram of what it does on paper, and you can do it analog or digital. I don't care. And then you're going to output for me 3 different versions of it. So you might take a screen capture, or you might print this out of Rhino for me. Okay, print what's in there, and I'll have a video for that. So you do that. Maybe you have one where you vary it a little bit more. You're going to give me 3 versions of it to show me what it does when you change the parameter. And then you're going to give me an output of your Rhino sketch from Grasshopper. You're just going to say export high-res image. That's going to give me a nice, beautiful image of your script. Put those 3 pages in a PDF and upload those to Moodle. Okay? Any last questions about this stuff? I hope you guys have fun with it. I find Grasshopper a lot of fun. And how much time do you have? You have till Sunday night for this. This is a typical assignment.
Not that bad. I promise.
Again, I have just recorded this entire lab for you guys, so you can go back and replay this on like YouTube. It'll be posted probably by noon. Okay. If you guys have questions, let me know. But again, what I would do is, I would like do the sketch, design it, okay, figure it out, then follow through the tutorial and start to like build the pieces of it and start to encode it, and then just kind of play with it, right? You might modify it based on what you see when you use the program. Okay.
Is it a column or is it a different?
It's a column. It's exactly what I just showed you, only it's yours. You're going to design, and again, if you guys want to experiment, if you guys totally, like, you think that this is really easy and you want to do something else, you can use different kinds of cross sections. So you could use a circle, and then you could use something that you draw yourself. You could use a hexagon in the middle there. You could experiment with it. You can make wacky columns. As long as there's a logic to it that's consistent, I don't care. This is about proportion, not necessarily about learning Grasshopper. Okay?
So when you save, like, just saving it,
Yeah.
you have to save the Grasshopper version and a Rhino version, or?
If you have a referenced thing, you need to save that Rhino file. That line that you drew will be in a file. And then the Grasshopper script will use that Rhino file. So yeah, you need the script and the Rhino file. That's a great question. Yeah, if you use any Rhino geometry, you need that Rhino file, so that 3D file. I don't need you guys to send me those files, though. All I care about are the images out of it. I'm not going to open up all these scripts and look at them. There's no way. It's too much, okay? But if you guys want to, I would say get in the habit of organizing these well, get in the habit of commenting them, get in the habit of naming them like meaningful things, just like you guys do with processing, okay? So you guys understand that. Cool. Thanks for hanging out with me. Sorry to keep you guys